Okay, so in this lesson, we're going to be going through index laws and the laws concerning multiplying and dividing powers. Our learning intentions: to understand the meaning of an expression in the form a to the power of n in terms of repeated multiplication of a, to know the meaning of the terms base, index, plural of indices, and expanded form, to be able to apply index law 1 when multiplying terms with the same base, to be able to apply index law 2 when dividing terms with the same base. Okay, so before we go on, let's just go through a little bit of terminology first. So here we have 3 raised to the power of 5. Now this 3 is what we call the base. This 5 goes by many names. We call it a power. We can also call it an exponent. And lastly, we can call it an index as well. So those are the 3 names that a power, exponent, and index are all what we call that 5. Now, what we call this right here, see we have 3 to the power of 5. Well, that means we just go 1, 2, 3, 4, 5. We have 3 times 3 times 3 times 3 times 3. 5 3's there. 1, 2, 3, 4, 5. So that's why we have a 5 there. We call this the expanded form. Perfect. Now, what we're going to be learning in this lesson is index law 1 and index law 2. Index law 1 tells us when multiplying powers with the same base, add the indices. So in this case, a raised to the power of m times a to the power of n, what you would do is you would add together the indices. And here's an example of that there. Index law 2 tells us when dividing powers with the same base, subtract the indices. So here we have a to the power of m divided by a to the power of n, and we're subtracting the indices. And here again is an example. Now at the very end of this lesson, we're going to revisit this section of the notes, but I actually want to kind of lead ourselves up to this. I don't want to go jump right in the pool. I first want to kind of dip our toes and slowly ease our way into it. Otherwise, it's just going to be, what on earth is going on? So let's just slowly go through it. All right, so let's kind of consolidate our learning a bit by reminding ourselves what indices do. So here it says, simplify the following expressions by writing them in index form. So if I have 5 times 5 times 5 times 5 times 5 times 5, how can I write that in index form? Well, I have 1, 2, 3, 4, 5, 6 5s. So that means I have a base of 5 and then an index of 6 here because I have 1, 2, 3, 4, 5, 6 5s. If I come over here, I have x times x times x times x. So that means x is my base, and I have 1, 2, 3, 4 of them. So 4 is my power. We come over here now. Here I have 11. Now I know 11 is going to go out the front. I have 2 a's, so that's a squared. Then I have 1, 2, 3 b's, so that's b cubed. And that's how I write it, just like that. Perfect. Let's now keep on going. Let's now kind of work backwards. So here it says expand these terms. We don't have to evaluate them. So if you see 2 raised to the power of 4, what that is 2 times 2 times 2 times 2. There's 4 of them there. If I have m to the power of 5, that's going to be m times m times m times m times m. So I have 5 of them there. If I have 4x to the 3, it's going to be 4 times x times x times x. So 3 x's and that 4 there as well. If I have 9, a to the power of 3, b squared, it's going to be 9 times, then I have 3 a's, and I have 2 b's. Let's keep on going. Let's come down here now. So that's kind of just consolidating everything so far. Let's now actually go into index law 1. So index law 1, when multiplying powers with the same base, add the indices. So a to the power of m times a to the power of n is just going to be a to the power of m plus n. Okay, example 1. Simplify the following using the index law for multiplication. All right, so here we have 9 to the 3 times 9 to the 2. So according to our index law here, what we would do is because we have 9 to the power of 3 times 9 to the power of 2, that's going to be equal to 9, 3 plus 2. And if we were to add these together, 3 plus 2 is going to be 9 to the 5. Now, why is that the case? Why is that true? Well, hopefully you left some space here as I wrote it down here. Let's now write this in expanded form. So if I have 9 to the power of 3, that's going to be 9 times 9 times 9. Then I have a multiplication sign here. Then I have 9 to the power of 2, so it's going to be 9 times 9. Now, how many 9s do I have here? I have 1, 2, 3, 4, 5. So that means that is the same as 9 to the power of 5. Now, obviously, a quicker way to do this would have just been 3 plus 2. 3 plus 2 is 5. So that's how this operates. Instead of kind of writing it out in expanded form and counting them up, you can simply say, hey, I have 3 9s here, I have 2 9s here, 3 plus 2 is 5. Perfect. Let's come over here now and do the same thing. So here's x cubed times x to the 4. According to index law 1, we could simply go, this is going to be x3 plus 4, which is going to be x to the 7. If we wanted to go the long way, we would have to go, all right, this is going to be x times x times x for those 3. Then I have 4 here, x times x times x times x. I have 1, 2, 3, 4, 5, 6, 7. So it's x to the 7. As you can see, this is a lot quicker, and that's why we use it. All right, let's come down here now. Now, this one's very important because it shows us the importance of this sentence right here. This says, when multiplying powers with the same base, they have to have the same base. If they don't have the same base, you can't add the indices. So in this case right here, what we would first do is we would say, all right, I have m to the 4, and I have m squared. So I'm going to go m to the 4 plus 2, and then I have n. Now this n here has an invisible 1 there. There's one of them. So n1 plus, then I have a 3 here, 3. So that means my final answer is going to be m to the 6, and then here is going to be n to the 4. That's going to be my final answer. If we were to do this the slow way, the expanded form way, which you actually shouldn't do, I'm just doing it to kind of show you what's going on. After a while, you'll just be using that way. But if I was to show you here, we have m to the 4. So that is m times m times m times m. Then I have n times n times n. Then I have n cubed. So that's n times n times n. Then I have times m squared. So that's 2 m's, like that. All right, so now what we have to do is figure out how many m's we have. Well, I have 1, 2, 3, 4 here, and I have 1, 2 here. So altogether, I have 6, and that's why we have a 6 there. And then we would grab another color, and I would say, how many n's do I have? I have 1, 2, 3, 4 n's, and that's why I have 4 here. And of course, the quicker way to do this is to say I have 1 n here, I have 3 n's there, that's why I have 4 n's. And then to say I have m to the 4, m to the 2, 4 plus 2 is 6. So you're adding together the indices in which you have the same base. That's very important. Okay, let's move over here now. So here we have a squared b squared times a cubed b squared. So what you're going to do here is say, all right, I have a squared and a cubed. Well, I'm going to plus these together. So I'm going to end up with a to the 5. And then for b, I have b squared and b squared. So 2 plus 2 is 4. That's going to be my answer. So you can see you can answer these pretty quickly. But again, just for the final time, just to show you what's going on here, if I was to write this out in expanded form, I have 2 a's here. I then have 2 b's. Then I have a times. Then I have 3 a's. Then I have 2 b's. Then you'd have to count up how many a's you have. So I have 1, 2, 3, 4, 5, and that's why we have a to the 5. Then you'd have to count up how many b's you have. I have 1, 2, 3, 4. So b to the 4. But again, you can see a lot quicker to go 2 plus 3 is 5. 2 plus 2 is 4. Okay, so with that being said, that is kind of the nuts and bolts of index law 1. We're now just going to go through some here, and we're going to answer them the quick way. So this is how you should be answering them after you feel really confident with them. So in tests and in textbooks questions, this is how you should be going about them. You should be going, all right, simplify the following using the index law for multiplication. X squared y times x cubed y squared. Well, here I have x squared, here I have x cubed. 2 plus 3 is 5, so it's going to be x to the 5. Then I have y squared. Now, there's an invisible 1 here because this means I have 1 y. So it's going to be 1 plus 2 is 3. Then we come over here. This is going to be, well, I have m here and I have m here. So it's going to be 3 plus 2 is 5, m to the 5. Then I have k and k7. Remember, there's an invisible 1 there. 1 plus 7 is 8, k to the 8. Then I just have a p by itself. We come over here. This time I have a number as well. So I'm just going to put that number out the front. Then I'm going to go, all right, how many r's do I have? I have r cubed here. I have r to the 10 here. So that means I have r to the 13 once I add those together. Then I have s to the 2 and s to the 5. That's going to be s to the 7. And then I have t2 as well. Let's come here now. As you can see now, I have a number here and a number here, and I'm just going to multiply those together. 8 times 3 is 24. Then a to the 4, a to the 5, that's going to be a to the 9. Then I'm going to have b to the invisible 1 there is going to be 3. We come here. Important to note here, I have one term that is negative and one that is positive. So that means my answer is going to be negative. 6 times 5 is 30. I have 2 x's here. I have 5 x's there. So it's going to be 7. 2 plus 5 is 7. Then I have 3. There's an invisible 1 there. 3 is going to be plus 1 is 4. It is 4. All right, perfect. We now move over here. As you can see, I have 2 terms that are both negative here, negative 6 and negative 7. 6 times 7 is, 42. And because they're both negative, my answer is positive. So when I multiply 2 negatives together, I get a positive out. And then I'm going to go, I have C9, C5. 9 plus 5 is going to be 14. Then I have D8, D2. 8 plus 2 is 10. And that's my answer. Perfect. Now, before we move on from index law 1, I just finally want to end on this example 3 here, and I've called it be careful. Lots of people make a mistake here. So if you're given this, you know you're going to be using index law 1 because you're multiplying 2 terms with the same base. So it's going to be a to the 4 because 2 plus 2 is 4. But if you're given a squared plus a squared, what you would say is, well, these are 2 like terms, so it's 2a squared. You don't do anything with the powers here. So make sure you know the difference when you're multiplying and when you're adding. Okay, let's come over here now. If I were multiplying these together, a to the 4 times a to the 3 is going to be a to the 7 because I'm just plussing together the powers because I'm multiplying here. If I was adding on the other hand, how can I simplify this? And the answer to that is you can't. These are 2 unlike terms. These are not like terms. So you actually just leave it as it is. Whoops. Because I can't join them together as I did over here because a squared, they're like terms. I can join them together. Finally, we come over here. So here I would say I have 1m, I have 1m. That's going to be m squared. Then I have 2n's, 2n's. So that's going to be n to the 4. 2 plus 2 is 4. Over here, these are like terms. I have 1m, I have 1m, I have 2n's, I have 2n's. So it's going to be 2mn squared. But there's a 2 there. So make sure you know the difference between gathering like terms and using that index law. So you have to keep your eye out as to whether you're multiplying or adding. I just see this a lot come up, people making mistakes. Okay, let's finish this off by now going through index law 2, which says when dividing powers with the same base, subtract the indices. So here we have a to the power of m over a to the power of n, and what you're doing when you have the same indice is, when you have the same base rather, when you have the same base, you're subtracting the indices. Okay, so let's go through some examples. Let's leave that up there. So simplify the following using the index law for division. So here we have 10 to the 4 divided by 10 to the 2. We have the same base. That's important. 10 and 10. We have the same base. So what this law tells us is we could go 10, 4 minus 2. 4 minus 2 is 10. So it's going to be 10 to the 2. Now, how exactly does that work? Well, what we're doing here is we're saying, hey, 10 to the 4, if I was to write that in expanded form, it's 10 times 10 times 10 times 10. And then if I was to go 10 to the 2, it's going to be 10 times 10. Now I can cancel out my common factors. So this 10 can cancel out with this 10. This 10 can cancel out with this 10, which means I'm just left with 10 times 10. So I come here and I go, I'm just left with 10 times 10. And 10 times 10 is 10 to the 2. So that's how it works. But as you can see, a lot easier way of doing it is just going 4 minus 2. Okay, so let's come to our next one now. And hopefully you can just look at this and immediately tell me what the answer is going to be. It's going to be 7 minus 2, which is going to be u to the 5. If we were to do this the long way, in the expanded form, you'd go u times u times u times u times u times u times u. So I have 1, 2, 3, 4, 5, 6, 7 u's there. Then here I have u times u. Then I would cancel out things that are both in the numerator and denominator. So this u would go away with this u would go away with this u, and now I'm left with 1, 2, 3, 4, 5 u's. And as you can see, that's what I originally said. So a lot quicker way of doing this is simply going, hey, this is u 7 minus 2. All right, last one, and then we'll go into some questions. Here, this would be, if I was to write this out the long way, it would be b times b times b times b times b, because I've got 5 b's, then I have 4 a's. Wow. 1, 2, 3, 4. Then on the bottom, I have 3 a's, a, and I also have 2 b's, times b times b. Now I cancel out what's common in the top and the bottom. So 2 a's here, 2 a's there. Oh, there's one more a, so 3 a's. Then I have 2 b's, 2 b's. Okay, what do I have left? I have 3 b's and 1 a. So that means what my answer is going to be is, so if I was to write this out, it's going to be b times b times b times a. So it's going to be a b to the 3. So that kind of took some time there. And did I did that correctly? Good. A quicker way to have done that is, again, you've got to look for the ones with the same base. We could have gone, hey, I have a to the 3 and a to the 4. 4 minus 3 is just a by itself, because 4 minus 3 is just 1, and there's an invisible 1 there. And then I would have gone, hey, I have b to the 5 and b to the 2. 5 minus 2 is 3. So that's why I have b to the 3. All right, so having gone through those long examples there, let's now quickly answer these questions here. So if I have f to the 9 and f to the 4, it's just going to be 9 minus, 5. F to the 9 over f to the 5 is just going to be 9 minus 5, which is going to be f to the 4. Here, if I have g to the 45 over g to the 5, it's going to be 45 minus 5, which is going to be g to 40. And then here, now this is one that I put in just to throw you. If I have h to the 100 over u to the 97, can I do anything here? Can I simplify this? And the answer is no, not the same base. This is h and this is u. They don't have the same base. So that means I can't simplify it. I would simply leave it as it is, and I just walk away. There's nothing I can do here. So this would be similar, and you don't have to write this down, but if I gave you h to the 2 times u to the 4, there's nothing you can do here. You just have to write this as, h squared u 4. You can't add those together using index law 1. You can't do it. Well, so too over here. You can't use index law 2 because these aren't the same. Okay, we come over here now. So again, we're going to look for the ones with the same base. Here I have m to the 5. Here I have m to the 4. 5 minus 4 is going to be 1. So that means I've just got m. And then here I've got 9 to the 7, n to the 7, and n to the 2. That's going to be n to the 5. We come over here. We notice that I have a 4 here. So let's just write that down. Then I have 19 minus 8. 19 minus 8 is going to be 11. Then for my e's, whenever you've got just e by itself, or any pronumeral by itself, there's an invisible 1 there. So that's going to be e to the 2 minus 1, which just means e, because this 2 is going to go away. So 2 minus 1 is just 1, so it means I've just got 1 e up the top. Let's come over here. So now I've got numbers on the top and the bottom, so I'm going to have to do some simplifying. I can divide them both by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. Now I have a to the 5 and a to the 17. I can go 17 minus 5 is going to be 12, and then this goes away. I have 7 and 2 here for my b's, so that means 7 minus 2 is going to be 5. And then for my c's, remember there's an invisible 1 here, so it's going to be 5 minus 1, which is going to leave me with 4 there. So my answer is going to be 2, a to the 12, b to the 5, c to the 4. And then there's a 1 in the bottom, but I don't have to write that. Because remember, anything over 1 is just that thing, so I don't have to put that 1 in. Okay, next. We have this one. So again, I'm going to have to simplify. I have 27 and 63. Both of those can be divided by 9. So that means 27 divided by 9 would be 3. 63 divided by 9 would be 7. Then I have a z here and 7 up here. So that's going to be 7 minus 1 is 6. Then I have h3, h8. That's going to be 5 there because 8 minus 3 is 5. And then nothing can be done with that g squared. So my answer is going to be 3, z to the 6, h to the 5 over just 7 on the bottom. That's the only thing left. We come over here. I have 14 and 56. Both of those are divisible by 7. So I'm going to have 2 and 8. Well, both of those are divisible by 2. So I'm going to have 1 and 4. Then I have 5 and 7. So 7 minus 5 is going to be 2. So it's going to be 2 there. So I'm going to be left with, I don't have to write down this 1. I've just got x squared on my top. So if I wanted to, I could put 1 there, but that's actually, we don't write it like that. We just write x squared by itself. Then I have 4, and then I have z to the 7 down the bottom. Come over here. Here I have 24 and 18. Both of those are divisible by 6. That will be 3. That will be 4. So it's going to be 4 and 3 there. And now I have s to the 7. And I have s to the 7. What's 7 minus? These just go away with each other. They're the same. They just go away. Then I have this. So it's going to be 12 minus 9, which is going to be 3. Oops. So I have 4t to the 3 over, then down here I just have 3. All right, so there you go. There is everything you need to know about index law 1 and 2. If we go back to the very start, you've got these examples here. And now having gone through everything, these examples are probably going to make more sense to you. So you can use these as references as you go on later. All right, so with all that being said, hopefully you found this lesson okay, and you can now answer all these, or you feel comfortable with all these learning intentions. I'll see you in the next lesson.